2.3, biconditionals and definitions. A biconditional is made up of two conditionals, hence the word bi means two. This means there's two conditional statements, like if P then Q, and then if Q then P, and it combines that as P if and only if Q. That's the key. P if and only if Q. Problem 1 talks about writing a biconditional. So you want to take a look at the first conditional. If the sum of two angles is 180 degrees, then two angles are supplementary. First things first, what I need to do is write the converse of the following conditional. If it's true, then you can write the statement as a biconditional. So if we take a look at this, let me change ink colors for you here. The converse of this statement, again, we took a look at if and then. So if two angles are supplementary, then the sum equals 180 degrees. Now you got to ask yourself the question, is that true? If two angles are supplementary, then the sum of the two angles equals 180 degrees. And we should know that that's true. So what we're going to go ahead and do is write this as a biconditional. So my biconditional is going to be the sum of two angles, and it really doesn't matter how you put it, but I always like to start with the first one. The sum of two angles is 180 degrees if and only if the two angles are supplementary. So the key words here, if and only if. Problem 2 is identifying conditionals in a biconditional. So you're kind of going backwards here. So again, I'm going to take a look at the word if and only if. That's kind of my break point. It says array is an angle bisector if and only if it divides an angle into two congruent angles. Now that's pretty much breaking up it into two conditional statements or two a hypothesis and a conclusion if you want to look at it that way. So number 1 would be if array is an angle bisector, then it divides an angle into two congruent angles. And again, I abbreviate because my handwriting is terrible and I'm trying to save you guys time. Now we just talked about the fact that there's two true conditionals that form a biconditional. So number 2 then would be just take and just change the hypothesis and conclusion. So if array divides, and again this is important, kind of an English thing. Array is your subject here. If you put if it divides, it's not technically wrong, but you want to specify what's dividing. So in this case, if array divides an angle into two congruent angles, then it is an angle bisector. Problem 3 is about writing a definition as a biconditional. Now what the instructions say here is this definition of quadrilateral reversible? If yes, write it as a true biconditional statement. Okay? So a quadrilateral is a polygon with 4 sides. Is that reversible? And by being reversible, again, my key word here is. We have a hypothesis, we have a conclusion. We'll talk about that in a second, but can I say that a polygon with 4 sides is a quadrilateral? Well, yeah, a polygon with 4 sides is a quadrilateral, so this definition is reversible. So I can go ahead and write this as a biconditional. Okay, so if I'm writing this, my biconditional would be a figure is a quadrilateral If and only if, again, there's your key words here. If, and let me erase that. Sorry about that. If and only if it is a polygon with 4 sides. Four sides. And there's your biconditional off of that definition. Well, yeah, that's what makes a good definition. There's a couple things when you're looking for it. First thing is it uses clearly understood terms. If there's some vague terms in it or things like that that you don't really know or doesn't describe something precisely, it's not an understood term. That's not a good definition. Again, second thing is it precise? Does it say exactly what you want it to say? There's no gray area anywhere in that definition? And the last is it reversible? Just like we talked about the last one. Can you take the first part in front of the is and flip it with after the is, and does it make sense still? Is it reversible? That's what makes a good definition.